Hello CIS18A students. This week we are covering Unit 2, which is Chapter 2 and 3. And for this week, we need to first check out the to-do list. The to-do list includes the objectives for Chapter 2 and Chapter 3. And I am recording the videos in 3 parts. The first part will go over the week materials, and also I wanted to cover data types in the first part. In the second part, I will cover operators, arithmetic, logical, and assignment operators, along with the conversion in the assignments and in expressions. And the last part is going to cover control statement and loops. So we need to take a look at if else, switch statement, while, do while, break, and continue. So the task for this week is to read the textbook if you have the textbook, chapter 2 and 3. If not, you can take a look at the notes. The notes include the core components from those chapters, so you can view the notes and also go over the videos. Then you need to complete Unit 2 lab and complete the Unit 2 homework assignments, which prepare you for next week quiz 1. You can also attempt the extra credit, which is quiz 1 review game. For the highest score, I will send a gift via email for the highest score winner. So for the notes, you can find that on the next page. And in the notes, it begins with talking about data types in chapter 2. And Java is a strongly typed language, so we would see that we need to specify the type when we declare variable arrays or even when we write function. And otherwise, the compiler will throw an error if you don't specify the type. Now, there are 8 primitive data types for Java. We have boolean, which is for true false values. So if you need to output true false, we would use boolean type. For byte, the system would allocate 8 bits to store whole number or integers. And so if you're using a smaller integer, then you can use byte as a type. Char is used to store character. That would be a single letter or a single character in the ASCII table. Double is used for double precision floating point. Something like price would be needing a double data type. Float is used for single precision floating point. An example of using float would be something like temperature conversion from Fahrenheit to Celsius, so we can use float for that. Or double would be okay if you want double precision point. That would be 2 decimal points after, or multiple decimal points after that. And for int, that would store whole number. And the difference between integer, int, using int and byte is that int is allocated a larger space in the memory compared to byte. Byte uses 8 bits, int uses 32-bit. Now for long is used when you have a very large integer, and long is given 64 bits as storage for that value. So on page 1, you would see 8 primitive types of data that can be used in Java. Now, on page 2, it specifies the type and the width of the bits. And this is important to know because when we're looking at the length of the number, the width of that number, how that's stored, we need to make sure that we allocate the appropriate type that would be able to fit or store the entire number. So Java does not support unsigned, positive only, or signed value compared to C++. So when you simply, if you use negative or positive number, you simply use the type that's specified on page 1 and 2. So in the example program, the book presented the example program showing you how to convert cubic inches into cubic mile. And we would start with the comment. This is the multi-line or a block comment. And then we would define our class. And here the class is named as inches. And inside that class, you have a main method. Inside the main method, you have the variables. So first variable that's declared is CI, and this is type long. Next variable is im, that's also type long. So once these variables are declared, we can then use arithmetic operator to multiply so we can convert inches, cubic inches to cubic mile. So for CI, for im, that will be 5,280 times 12, and that would store the value for the mile. Then we would then cube the inch conversion from inches to mile by multiplying the im by itself 3 times. So im times im times im is going to give us the cubic miles value that would be stored in CI. And the reason why we're using long here is that we're expecting the number to be very large. So when we output this, system out print line that allows us to display the text, and the first string is there are. Then we would append the value from CI after we multiply it or cube it, and then we would output the next string, cubic inches in cubic miles. So when you take a look at this program, I have this program written in Notepad. I then would save this program as inches.java. Make sure it's all files here, and I place it in the folder where I can find it. And make sure that the name of my file is exactly matching the name of the class, and that's important. We're going to go ahead and click save. And then I would use my command prompt, which is Windows command line. I changed my directory to the folder where I store the file. Then I would compile the program by using javac inches.java. We gotta make sure that the file extension is there when we compile. With no errors, then now I can run the program by using Java and just inches without the file extension. So here it provides me with the output. There are, and here as you can see, this is the reason why we have a very large number. So this is the reason why we use long for that data type, because we have a very large number. And as you can see, this is the program that's presented in the notes and also in your textbook. And on page 3, it gives you the explanation why we did not use byte, why we did not use int, as the number is very large. Once we cube it, then we would want to use long. So you have to select the appropriate data type, and we need to plan that as we approach a program. When we solve a problem, we want to make sure that we think about the data type that we're going to use in our program. In the next example, this is an example to show floating points. And in this program, we're expected to use decimal. So this program is used to find the length of the hypotenuse given the lengths of the two opposing sides. So to start, we have class hypot. This is the name of our class, so we're going to have to save our program as hypot.java. Here's the main method. Under the main method, we have double x, y, and z. Previously, you learned to declare the variables separately, but yes, you can declare them together like this as long as you use comma as a separator between. So you only have to state the type once, and then you can include different variable names for your program as long on the same line as long as they use the same data type. Finish that out with the semicolon. Next, we would do variable assignment. So here, once we declare the variable, we can assign it a value. So x, we're going to say that it is 3. Y is 4. And then for z, what we want to do is we want to use z to store the square root of x squared plus y squared, as that would be the formula for Pythagorean theorem. So here you notice that we're using math dot square root. So this is the method that's called from the math library to be able to give you the result for the square root of x times x plus y times y. And we want to make sure that the brace is, we open the brace and close the brace for x times x plus y times y. Then we would print out the output. So here we would have system out print line to display the text and the value after the calculation. And then we have the closing braces. So that would be the program to be able to calculate. And different from the previous program, we're using double. Then next, we are also for z, we are also using square root from the math library to be able to operate the square root after we multiply the x plus y squared there. So based on that, I want to show you the program that's written here that I have, and then I will go ahead and save it as hypot.java, as it needs to be exactly as the class name. We're going to go ahead and click save. So once we saved it, then we can run this program to look at the output. So I have issued the command javac hypot.java to run. I didn't receive any error as all the syntax is correct. Then I would run the program java hypot without the file extension. And I see here that the program output hypotenuse is 5.0. And as you can see, we have a decimal point here. So therefore, that's why we use double instead of int, because int would not include the decimal point there. Int will only store the whole number. And another primitive type is char, or for characters. And characters in Java are not 8-bit quantities. Java uses Unicode, as it says here, and Unicode defines a character set that can represent all characters found in all human languages. So char is allocated 16-bit, and it would have a range from 0 to 65,535. So for the ASCII characters, that would still be valid under Java characters, but Java does use Unicode, and the character variable can be assigned a value by enclosing the character in a single quote. So that's important to note. So we want to make sure that we use a single quote around the character that we want to assign to the variable, as what is shown here. So in this example, we have char as a type, and the name of our variable is ch. Once we declare the variable, we then assign it a letter. So we would have ch is, and here we're using a capital X, so we need to put a single quotation mark around the capital X and finish it out with the semicolon. So when we print this, we would do a system out print line. This is a string that we wanted to go before we bring down the character. So this is ch, and then we would append the character by using the variable name here inside that parameter. So for this program, for the example program that's shown on page 4, what we have here is a program that we wanted to use the character variables like integers. So first we have a class called char arith_demo, and inside that class we have a main method. We declare our variable ch as to store characters, so the type is here, and we initialize that variable. We assign it a value, which is capital X with a single quotation mark. We then output by using system out print line, and ch contains, then we bring down the variable name here to show, so X would plug in when it would display as output for text. Then on the next line, we would increment ch. So X is going to be incremented by 1. So when we're using the increment operator here, then we would output by using system out print line. Ch is now, and the value that the character that is gonna be incremented. So after X, it should show Y. After that, we reassign it a numerical value. Ch is 90, giving ch is a value Z. So how can you tell the decimal equivalent, the value equivalent, the number numerical equivalent of this to the letter? You can also check the ASCII table, so that way you can see what character it is for the value 90. System out print line is the next line for this program to show the character, and it should output C here. So I have the program written in Notepad, and I already had saved this as the same name as my class name. And then I will go ahead and open my command prompt, and I will issue the compile command. And we're going to make sure that this is exactly the way you name your file, which is the same name as your class. Once it's compiled successfully, we would run the program. And so as you can see, when we first output X here for CH, but when we increment it, it would then add 1 to the decimal equivalent of X. And when we increment it by 1, it's going to go to the next letter, which is Y. And then when we reassign CH, when we initialize CH as 90, so at this point we update it with 90 as decimal value or numerical value. So right here, that would be x and then +1. And then when we update it with 90, that's going to give us the z equivalent. So it converts that to a character as we had typed it as a char. So at this point, we are displaying z for 90 because it would convert the numerical value to a character. So the equivalence of that number, that will be the character that's going to be displayed, which is c. So we would start with x is 88 is the decimal equivalent for x, and then 89 is when we increment it, and then 90 is the z. So when you type it as character, it would output it as character. So even if we had assigned it a numerical value, it would refer to the type and convert that to a character for us. So here it gives you the explanation on how that program works. And so as you can see, ASCII and Unicode sequence and the equivalence value as it explained there. Next, I'm going to talk about Boolean type. And for Boolean, Java defines a value true, false using reserved words true and false. So these are the reserved words. So when we use Boolean type, we can output true, false, or use true, false in our program. So in this program, this is just to illustrate true, false being used, or Boolean values being used in a program. So here we define a class called booldemo, and in that class we have a main method, and in the main we declare the variable b and its type is Boolean. Then we assign it false, so b is false. So we initialize it as false here, and then we have it printed. Then next we reassign it as true. So we update from false to true, and then we would then output. So it should say b is false for the first print line, and then after we reassign it with true, it should say b is true for the next print line. Then next we would include an if statement. If b, then we would output this is executed. So if it's true, it's going to be executed. Now notice that we're using the if statement here, and the if statement will check for the condition that is true. Since we already assigned it as true here, it will execute system out print line. So it would execute this is executed string as an output. Then next we have it reassign it again to false. So b is updated to false at this point. And we have an if statement. If b, system out print line, this is not executed. Since we have updated with the false value, when it gets into the if statement here, it would not check true, so it would skip this and not execute this particular line, this part of the line. Then it's going to come to here, and then it's going to try to output 10 is greater than 9 is, and it's concatenating, it's going to include 10 is greater than 9. And this is going to say true. So as 10 is greater than 9, that is true. It's going to convert this and give you true. So after I have saved this program as booldemo.java, I would then compile and run it. So here I simply issue after I compiled the program successfully, I would then run the program. And so as you can see, we have B is false, and that would be this output right here as we assign it false here. So that's going to get plugged into here. So the first output we have is B is false. Then we reassign it true. Then that's the second output, B is true. Then for the if statement, because it's true, it this is executed. So that's right here. Then next, we reassign it again to false because it did not check true for this if statement. It skips this, so that was not displayed. Then it's going to go to the next line, so it displayed 10 is greater than 9 is, and because inside this 10 is greater than 9, that's true, it gives us the true. So as you can see, you can use it like this for the bool type, and so it would give you the output true when you're using 10 is greater than 9 like this as well. Okay, so that's an example of how Boolean values is used in a Java program. Next, I want to talk about literals for Java. And literals are just fixed values that can be represented in human readable form. So something that is fixed is not changeable, and this is what you would see as constant in C++. Literals are also known as constants, so sometimes you would hear people refer to that as constants. For Java, we would call that literals. So Java literals can be any of the primitive data types. Unlike C++, C++ uses constant const for the data type. So for this, what we can say is we can have a literal of a certain value, and that can be used with any of the data type. So here it talks about floating point literals required to use the decimal points, following by the fraction components. So when you have some decimal value as floating point literals, you can also use scientific notation, very similar to what you've seen in C++. But for float literals, you can use F, capital F, or lowercase f to the constant, like this, 10.19f. Next, we're going to talk about hexadecimal, octal, and binary literals. So we can use hex to include hexadecimal number and hexadecimal value. And the number system for hex is base 16. And sometimes you would see hex being used for memory addresses. Hex can be used for IP version 6 address. Hex can be used for the color code in HTML. And octal is more of a legacy number system, and it is base 8. And so for the octal, octal can be implemented to get the parallel or equivalence in other decimal number, but octal was formally implemented in the older system for the 8-bit and 16-bit system. So here it talks about hexadecimal and octal. You might see some of this in CIS11 or CIS7. I normally go over the conversion of this. And for decimal number system is our counting number 0 through 9, and it repeats. But for hexadecimal, we would have 0 through 9 and A through F. A stands for 10, B stands for 11, and so forth. And when it reaches F, that will be equivalent to 15 in decimal value. And sometimes you would see hexadecimal being represented with number and letters. As once it reaches 10, it would go from to A, and then 15 will be F. So for the next part, we need to talk about character escape sequence. So if you need to use escape sequence is often used to in display for string. Maybe we need to align certain columns and rows when we're displaying text. So here is a table that provides you with the escape sequence. So if we wanted to include tab, we would use /t. Or if we wanted to include a new line, we can use /n, and this is commonly used to display text as well. So here is a list of the commonly used escape sequence for Java. And as we mentioned that escape sequence is often used with string or text, Java supports other type of literals such as string, and you would see this in the earlier programs in week 1, where we would use a double quotation to display a certain phrase and a group of text. So a way that we can format it, or we can align the string to look a certain way, is we can use escape sequence. And so here is a very short program to demonstrate the escape sequence in string. So with this, as always, Java start with the class, and we would define that class by giving it a name and start with a curly brace. Then we would have a main method, and inside that main method we can output specific string, which we use double quotation mark. And in this case, when we output the string, we include an escape sequence, and this is /n, so that means it's going to break this into 2 separate lines. First line, and then it's going to drop the second line onto the second line. Then on the next one, we would output A, and then tab, and then B, and then tab C. So you can use tab to align columns if you need specific text to be in column. And also on the third line here, we would output D, and then we would tab F, and we would tab E. So to demonstrate this, I will take you to the program and run that program so you can see. So here's the example program of using escape sequence. And as I explained, this line right here allows us to use the escape sequence /n, which goes to the new line. So it's going to break the first line and the second line into 2 separate lines, as we can see here. Then the next one, we have A, then tab B, tab C. So A, and then it tabs B and tabs C. D, tab E, and tab F. So that's what you see. And this is where we can line up characters into columns. So we can do it this way, or we can use other escape sequence to make sure that we output text the way we want. So that illustrates how you can use escape sequence in Java. And you can find that on page 8 of your note. So on the bottom of page 8, it talks about variables. And last week we talked about how we would declare a variable, how we would assign value to that variable. And again, this week we talked about variable assignment. Now, the type and the data type of the variable and its name is important when you plan to write the program. And it says that the type of the variable cannot change during its lifetime. So once you have selected the type for that variable, you cannot change it throughout the program. You can only change its assignment, or if you initialize it with a certain value, you can update it with another value, as what we've seen with the CH program from 2 examples ago. So when you initialize the variable, you basically give it a value. So it says here that you must give a variable a value prior to using it. And you would do this through an assignment statement like this one. We would have an int count. Int is the type and count is the variable name, and we would initialize it at 10. So this is a whole number, therefore we use integer here. And so we would give it a value, and so we would do an assignment statement here. And again, for the next one, we have char ch, and then we assign it x. Float f, we assign it 1.2, and the f indicates that it's a float. So that is a way that you can do initialization for variable. You can also have dynamic initialization, and this is an example of how we can dynamically initialize at runtime. And in this program, we have a class called dyne init, and in the main method, we have a variable called radius, and its type is double. And it's initialized at 4, so radius is initialized at 4. It's assigned 4. Height is also the double type, as we use a comma right here. That simply tells us that it uses the same type as radius, and it's initialized at 5. So now, in the next part, we would then have dynamically initialize the volume. So volume is also type double, and we would take pi, which is 3.1416, times radius. It's going to take the 4 and plug it here, times radius again, because we have to square it, times height. We're going to plug the 5 in. So the volume is dynamically initialized at the runtime, as we would use other variables and values for the calculation of the volume. Then on the next line, we simply output the string volume is, and then plug in the result after the calculation here to show. And the last part for the part 1 with the type and the variables, here the section talks about the scope and the lifetime of variable. And so in each of the block of your code, that section, that really defines the scope of the variable. And so every time there's a declaration, it would create the scope of that. Later on, when we get to the control statement, you would see that the scope of the variable that's defined in the control statement is only valid for that scope, that section of the code, unless it's globalized. So here it says that the two most common scope for Java are those defined by a class and those defined by a method. So it's either in the class or also in the method. And it's defined by the method begins with its opening curly brace. So how do you know? You're going to look for the curly brace when it starts that method. So going back to here, what we see is when we define a class, we open a curly brace here, and here's the void main method. You would have the curly brace, and that's going to really define the scope for that method within here. Now, variable declared within the block is called the local variable. So if we define it within the main here, like what you've seen in the example, if we declare the variable within the main, like this, double radius, double height, that's going to be local as it is, its scope is within that block. Now, if you want the variable to be usable across all the classes, it needs to be global. And we would address that in a later chapter. So it talks about how the objects declared within the inner scope will not be visible outside of it. So outside of that method or outside of that scope, it would not be usable, it would not be accessible or be seen outside of that. So when we start nesting within the scope, when you nest it from the inside, the outside might not be visible to that. So when you're looking at the program, for example, like this program here, we would have scope demo, and we would have the main method. Inside main, you have int x, which is known to all the code within main. So as long as it's within main, it would be able to see x. X is initialized at 10. If x is 10, this is start of a new scope, int y is 20. So y is initialized at 20, and it's only going to be seen within this area. It will not be usable outside of that, outside of the if statement. Okay? And x and y are both known here only. Okay? Then we would output x is y times 2, which is it's going to take 20 times 2. And once we finish out this curly brace, we have to reassign, right? Because y here is no longer the same as what we had previously assigned. So y here, it says that when you do this, it's not going to know what y is because y is only inside this particular scope. It is only known to this scope. So it's going to throw an error if you're using y out here because it's only going to be seen inside. So if you want y to be used, then we would have to put it above the if statement. Would have x is 10 and y is 20. As it's used on the inside, it won't be accessible beyond the curly brace. Okay. So at the end, we would have it output x is x. So here it gives you a brief explanation of what that is, and you can check out that program and play with it a little bit when you test it, so you can be sure on how it's used within a specific scope and how it is a local variable. So it says here that variables are created when their scope is entered and destroyed when their scope is left. That means that when we close out that brace, that will be destroyed. The variable will not hold its value once it's gone out of the scope. Okay. So here it touches on how each block needs to be declared. So if no variable is declared within the inner scope, it can have the same name as a variable declared by enclosing the scope, but should not be with practice, but it could be done. So this concludes part 1 of my lecture. Please look at part 2, in which I cover operators, and we will talk about different types of operators, from arithmetic to logical operators and assignment operator. Thank you.